Falling to Saturn is a rather extreme and, in fact, irreversible event for any spacecraft. Let's imagine a hypothetical scenario in which a spacecraft embarks on a journey to Saturn and at some point finds itself on its way to its atmosphere, with the intention of diving onto the planet. Preparing for a flight to Saturn, Saturn is the sixth planet from the Sun, and its distance from Earth is about 1.2 billion kilometers, 1.2 astronomical units. In order to reach Saturn, the spacecraft needs to travel a huge distance and use either gravitational maneuvers or powerful engines. The spacecraft could be equipped with modern engines, such as ion engines, which are effective for long-range space flights, but they do not provide high thrust, which means that the journey would take a long time. About 7 years, as was the case with the Cassini mission, which studied Saturn and its moons from 2004 to 2017. Years. Approaching Saturn. When a spacecraft begins to approach Saturn, it must consider several factors. Saturn's gravitational field. This field is much stronger than on Earth and attracts all objects to itself, including spacecraft. If the ship gets too close to the planet, it will start to accelerate, and gravity will start to play a crucial role. Saturn's atmosphere. Saturn does not have a solid surface because it is a gas giant. However, its atmosphere, consisting mainly of hydrogen and helium, gradually becomes denser as it approaches the center of the planet. It is impossible to launch from Saturn because there is no solid surface and a sufficiently large lifting force. Entering the atmosphere. When a spacecraft enters Saturn's atmosphere, several problems arise. High speed. The spacecraft, moving towards Saturn, has tremendous speed. For example, the speed of the orbital motion of Saturn's satellites near the planet is several tens of kilometers per second. Upon entering the atmosphere, this speed will decrease dramatically due to atmospheric resistance. Friction with the atmosphere. Saturn's atmosphere consists of various gases and clouds, which gradually move from less dense layers to more dense ones. At an altitude of about 1,000 kilometers above the clouds, friction with the atmosphere will begin to heat the spacecraft. In these layers, the pressure and temperature begin to increase dramatically, and the ship will face extreme conditions. Thermal effects. When falling through the atmosphere, as in the case of any other planetary body, the ship will encounter a very strong thermal effect. In Saturn's atmosphere, temperature and pressure begin to rise sharply at great depths. Heating. Due to friction with gases, the temperature of the ship's outer shell can reach thousands of degrees Celsius, which will require the use of high-quality thermal insulation materials to avoid destruction. Atmospheric layers. At a deeper level of the atmosphere, the pressure will become so high that the ship's material will begin to shrink, and additional difficulties will arise due to dense clouds and storms. Resistance and destruction. After the ship enters deeper layers of the atmosphere, the speed of its fall will increase significantly, and the density of the atmosphere will become so high that any resistance will be catastrophic. It is almost impossible to slow down smoothly in such conditions, and as soon as the ship is at a depth of several hundred kilometers, where the pressure is already 10 times higher than Earth's, destruction will be inevitable. Falling into the depths. With depth, pressure and temperature will increase, which will lead to the rupture of the spacecraft shell. Dense clouds consisting of ammonia, methane, and water droplets will begin to penetrate the hull, destroying electronics and life support systems. Deep layers. As you go deeper, the ship will simply be destroyed by the pressure, temperature, and chemical activity in the atmosphere.